Welcome guys to my YouTube channel The Medic Man. Today I am going to teach you how the electrical conducting system of heart works, and one more surprise with that, how the action potential get generated in the heart. So here we can see how the impulse travel. There are total four different types of pacemaker in the heart. First is the SN node, then second is AV node, third is bundle of His, and lastly the Purkinje fibers. We can see the SN node. The SN node is located at the upper right quadrant of the heart, and the AV node it is located in the lower left quadrant of the heart. When impulse get generated in the right atrium, first, it is travel from sinoatrial node, that is SN node, also known as Kth and Fleck nodes, to the atrioventricular nodes, and from atrioventricular nodes to the bundle of His, from bundle of His to the left bundle branch and the right bundle branch. And one more thing, from left bundle branch to right bundle branch, the impulse gets distributed towards the Purkinje fibers, and from there, the total depolarization, that is contraction of the ventricles take place. So as we are getting that the impulse are traveling from SA node to AV node, from AV node to bundle of His, from bundle of His to left and right bundle branch. So as the impulse is traveling, some events also occurs in the heart. That is, first the atrial activity, second is no electrical activity, and third is ventricular activity. So what is atrial activity? Atrial activity can be defined as when the impulse travels from SN node to AV node. Here, the complete depolarization, that is complete contraction of both the atrium take place. From AV node to bundle of His has no electrical impulses plus. This is known as no electrical activity, or also known as normal delay. From AV node, the impulse get transferred to the left bundle branch and right bundle branch, and from there to the left Purkinje fibers and the right Purkinje fibers respectively. So, and here the complete depolarization of the ventricles take place. This is known as ventricular activity. So now we will say that how the action potential gets generated in the heart muscles. This is not valid for the atrium, it is valid for the ventricular muscles. So first we have to know that how the ions are distributed across the cell membrane. So first of all, we are seeing that the concentration of the ions at resting membrane potential. The resting membrane potential is about 90 millivolt for almost all the cells of the body. So there are three major ions which plays a vital role in generating the action potential. First is the sodium, second is calcium, and third is potassium. So we can see here that the sodium concentration is always high in the extracellular fluid and low in the intracellular fluid. Potassium concentration is high in the intracellular fluid and low in the extracellular fluid, while the calcium concentration is high in the extracellular fluid and low in the intracellular fluid. Further, after when the impulse travel from SN node to AV node, okay, here we are seeing that the impulse are traveling from SN node to AV node, and when the impulse travels from AV node, okay, let me clear that when the impulse travels from AV node, the resting membrane potential which is at 90 millivolt, here as soon as the bombarding of the electrical impulses take place, first of all the first channels or the first ions to be displaced is the sodium ions. So we can see here that the first impulse has it received the first impulse, the voltage gated fast sodium channels opens, and as soon as the fast sodium channel opens, there is the rapid influx of the sodium ion in the intracellular fluid of the heart cells. After that, these the voltage changes from 90 millivolt to 15 plus 15 or 30 millivolt, and this is called as phase 0 or upstroke or initial depolarization of the ventricular muscles. Now, after opening of the fast sodium channels, then the second stage is that the fast sodium channel gets closed. After closing of the fast sodium channels, now we can see that the fast potassium channels get open. Okay, after the initial depolarization, that is after the opening and closing of the sodium channel, after depolarization, the first gate, so potassium gated channels open, and there is a efflux of the potassium in the extracellular fluid. As we already seen that the potassium concentration inside the cell is negative, so for generating of the action potential, need to we need to get generate the positive charge inside the cells. So we have to move out the potassium ions from the cell. Now the fast as soon as the potassium channels move out of the cell, the action potential gets generates. Now the potassium channels gets closed. Here it is known as phase 1 or initial repolarization of the ventricular cells. Now, after the activity of the potassium channels, now there is the activity of L-type calcium channels. Okay, the membrane of the heart cells has L-type calcium channels. L means long lasting, but I can preferably call it has the lazy channels because it is quite lazy, very lazy, as it opens slowly and also gets closed slowly. Here, the influx of the calcium ions is very slow, so the depolarization phase maintained for a certain period, and this is known as phase 2 or plateau phase of the electrical activity of heart. Now, after the calcium channels gets closed, after this the potassium channel gets closed, and the again the sorry, let me clear that. After this the calcium channel gets closed and potassium channel gets open. Efflux of potassium take place, and this is known as phase 3. Here rapid efflux of the potassium take place, and the voltage comes down to minus 90 millivolt again, and this is known as resting membrane potential. This is also known as phase 4 of the electrical activity of the heart. Now, after studying all this, there is ion balance theory, how the heart muscles actually balances its ions after the depolarization. That is how it maintains the resting membrane potential. So there are total 3 pumps. There is sodium potassium ATPase pump, sodium calcium exchanger, and calcium ATPase. So for maintaining the negative membrane potential, we have to first move the sodium outside and calcium outside and potassium inside the cell. So sodium potassium ATPase, what it does that it remove 3 sodium ions outside the cell, and there is an influx of 2 potassium ion inside the cell. Then sodium calcium exchanger, what it does that it exchange the 3 potassium ion in the form of calcium, in the form of 1 calcium ions. Okay, in the exchange of 1 calcium ion, here more positive charge get released outside the cells. And the calcium ATPase, what does calcium ATPase does? Here the calcium get released outside the cell, and the cell membrane potential is re-established. So here we can see by the graphical representation of the electrical activity or the generation of action potential. So here we have seen that the depolarization of the ventricles or the phase 0, where the influx of sodium ion and take place, rapid influx of sodium ion take place. There is a then that fast gated sodium channel get closed here, and the potassium channel get opens. This is known as phase 1. After that the potassium channel gets closed, and this is phase 2 or the plateau phase, where there is increased calcium concentration inside the cells. These calcium channels are lazy, so the phase 2 remains at a certain level. This is known as plateau phase. That after that, the rapid repolarization of the cells take place. Here what is happened, that is the calcium channel get closed and potassium channel gets open. There is rapid influx of the potassium ion in the cell, which leads to generation which leads to generate the negative membrane potential. And lastly, by activity of all the sodium potassium pump, sodium calcium exchanger, and calcium ATPase, then here the final resting membrane potential, that is minus 90 millivolt, is re-established. That is how we have seen the electrical conduction of the heart and also the generation of action potential in the heart. Thank you. And lastly, do subscribe my YouTube channel and share with your friends. Thank you. Bye.